everyone, welcome back my YouTube channel. I hope you all are good. So last video I discussed breadth first travelers. So this video I hope to discuss tree representation under the data structured and algorithm. So this video is fourth video in this series. So let's start the video. End of this video you can learn what is tree, simple idea about tree, and tree representation. Under the tree representation there are two categories, list representation and array representation. So these two parts I will discuss, and they are code implementation. Array representation, code implementation, and list representation, code implementation. So let's move to the video. First of all, we have to know what is tree. Tree is a nonlinear data structure where nodes are organized in hierarchy. Now let's see how about tree structure. The tree structure has many components: root nodes, edges, children, childs, subtrees, leaf nodes, levels, edges, a lot of components. I will show simple tree structure. So look at this image, you can get a superb idea about how about tree structure and tree components. So look at this image. The top of the tree, I will point at. Look at this. This is a root node. The root node represents all the tree. So the root node divided into two childs. It means root node divided into two parts. These are root node childrens. We call child nodes. So the child node divided into the one child node divided into two child again. So look at this triangle. We can get this part another tree, like a subtree. D and E is children of the B, and B is children of the A. Okay, and edges. Edges means the two nodes connect together. That connected part we called edge. So leaf node means there are no degree. Their degree is 0. We call them nodes leaf nodes. So I will explain what is degree. Look at this J. Their degree is 2. Degree is there are how many children? The J has 2 children. That means J degree is 2. Look at this C. There has also 2 children. So C degree is 2. Now look at this P. There are no childs. It means P degree is 0. It means P is a leaf node. Okay, now I think you have a simple idea about what is tree. So let's move to the representation parts. I will tell earlier tree structure there has two representation parts, list representation and array representation. I will discuss two representation in this video. First, I will discuss about array representation. So let's move to the array representation part. This array representation we called another name, sequential representation of binary tree. This representation we use one-dimensional array. It means simple techniques but inefficient at as it is requires a lot of memory space. Example, you are not coding knowledge, you have a coding knowledge. So example, get a array, the name is tree. So store element of the tree. Data of the root of the tree is stored in the first location. It means array has a indexes, the root not always is stored in 0 index. So this says that as a empty tree or sub is an empty tree or subtree is specified using null. If tree equals 0 null, then tree is empty. It means the array indices the 0 index is null, the all tree is empty. So that's the implementation part. So how represent binary tree in a sequential? So look at this image. I will explain step by step how sequential represent working. There are array and a tree. Okay, this is the tree and this is the array. I say earlier, always root not is stored in 0 index. Sometime 0 index is null, there isn't a tree. Okay, so this is the root node, it's in a 0 index. So next, after the first 0 level, then after the comes first level. This is the first level. After the first level, then store 18, 32. The 18 and 32 are children nodes of 25. Always store in data in the array left to right. So left child is 18. This is stored index 1. Right child is 32. It's stored in index 2. Then complete the level 1. It after come second level. Then like a before, left to right is stored in nodes in the array 12, 20, 28, 35. Then after complete this level and come again third level. Then after left to right like a before 19, 22, 33. Now let's see how identify each node left child and right child indexes. There are two equations for left child and right child. First one is this one, left child. How to find left child index? We can find left child index in this equation, and we can find right child index in this equation. Okay, let's see. We can get, for example, this 25 not. Now we can found 25 left child node index. So let's see. The left child node equation is 2k plus 1. The k means parents node index. The 25 index number is 0. So 2k plus 1 equal 1. It means 25 left child is stored in index 1. Look at this. This is correct. Now let's see right child. Right child equation is 2k plus 2. 0 plus 2. This is stored in 2 index. So now let's see 18 node. Left child equation is 2k plus 1. The 18 index number is 1. The answer is 3. You can see the left child index in 18 is stored in 3rd index. Another nodes are like same. So this is the sequential representation about trees. Now let's move to the list representation about tree. Linked representation of a binary tree. In linked representation, every node will have 3 parts: data element, pointer to left node, pointer to right node. Every binary tree has a pointed root. Points to the root element, and if root equal null, the tree is empty. Now let's see this image. You can identify and understand how list representation works. I said earlier, there has 3 parts. The 3 parts is left element pointer, right node pointer, and data element. So these are this tree, and so the first one is pointer to left, second one is pointer to data, and third one is pointer to right child. Look at this tree. The tree is root node. This is list representation. Look at this node. This is data element. The data element is 1. This address left child is 2. This address right child is 3. Look at this. This linked node, always they are left child and right child. This node is like same. This address left child, and this side address right child. all are the like this. Look at these leaf nodes. The leaf nodes didn't have any one of left child or right child. So these addresses are null. This says the addresses are null. When addresses are null, there isn't children in this node. So this is the linked representation about a binary tree. I think now you have a simple idea about how working list representation and array representation. Now let's move to the code implementation about array representation. The code implementation about array representation of a binary tree. First of all, look at this code. This is a I'll do this code NetBeans IDE in Java. So first of all, I create a class, public class, to code this array implementation. So I will explain line by line. You can get a good idea how it's working. So look at this first line. This is a creating a class, Java class. The class to represent complete binary tree using with array. So the second line is private int tree. This is a array, declaring an array. The third line is private int size, number of element currently in the tree. This variable represent. Now constructor to initialize the tree with given capacity. This code part. And I create a method. This method I will create to add new element to the tree. If size greater than or equal tree length, this part check if the tree is full or not. System out println tree is full. Then after this line, add the new value to the current size index, size plus plus. Increase the array size by 1. This method is over. Now move to the next method. This method I will create print the element of the tree in the array. This is a for loop. This you all now have a idea about coding knowledge. So there's line by line I using comment. You can read this and get idea. And this method I'll create get index to left child of a node at given index. So and this method is right for child, right child to get index of the right child at node at the given index. This is another method. This method I will create get to the index of the parent or node at given index. This is our code main method. This main method part we are creating the below methods calling in the main method. This is a object calling create the with capacity 10. We are creating a tree with the capacity 10. This line is add 2 element to the tree. So let's run and check the output. So you can see the output. 3 elements 10, 20, 30, 40, 50, 60 and 70. Present of node index 3 equal 20. Left child of the node at index 40. Right child of the node at index 50. This is the array representation about binary tree. This code I using line by line comment, so you can get idea about line by line how does code working. Now let's move to the linked representation code implementation about binary tree. This code also I'll using comment line by line, easily understand. First I create a class. This class represent to node in binary tree. I tell earlier the list representation has 3 parts: left node, child node, left node, right node, and data element. So this 3 node I define to represent that parts. So int value, the value of the node, 3 node left, it represent to left child, and 3 node right, it represent right child. The constructor initialize the node with the given values. This part I using this instructor using this given the values to give values these variables. So this is the class I'll create. This class represent to binary tree using linked list structure. This is the main class, not a main method, this is a main class. So root node of the binary tree, this variable. This method I will create insert new node to the tree. This is one parameterized method, and this part use helper method to insert new node recursively. It means the one node we add to the tree, we have to add another node. So this part do that. Create the new node if current position is null. Insert the left subtree, insert to right subtree. This part do that. So this is another method. In order travel to display structure. This means this code part used to display our output. This is our code main method. This main method I will use to we are creating below methods to call here. So let's run and check output. Now you can see the output 30, 20, 30, 40, 50, 60 in order travels. So this is the end of the list representation code implementation. So I think you have a good idea about list representation and array representation. We are come to the end of the video. Then bye bye.